Everybody. He's milking the supply house. Yeah, that's funny. And that's a nice, nice memorial comments there for that compressor. I think that works out pretty well. Let's see, my chat going here. Sorry, trying to do this over lunch, but it's rarely that simple. So let me get the comments pulled up. I know there was quite a few questions about the failure itself. So probably one of the biggest ones that came up that I want to speak towards, which was probably our biggest learning lesson throughout the entire thing, was okay. So when we first got in there and we first got going, why didn't we start with a full recovery? And I wanted to talk a little deeper about that. And genuinely, hindsight, I wish we would have. Now, this is the first time I had ever seen a failure like this. This was a new. Having that liquid valve fail or liquid sensor fail was an entirely new experience for me. So, if it didn't fully make sense, I tried to, but in the video, ultimately, when that liquid sensor failed, it failed at a low state. And so when I say low state, it was reading 5%. Now that system usually runs, I forget the actual set point on it off memory, but it was somewhere between 10 to like 40%, somewhere in there. And it fluctuates pretty heavily. But the point is 5% is considered low for that system. So what it was going to try to do is it was going to open the feed valve consistently until it was able to see that flash tank level come up so that it can feed the drain valve properly. Well, because the liquid sensor failed, it couldn't register the level sensor in the system properly, which allowed the system to eventually fill the tank to the point where it literally flooded the compressor back. Now, if you're not familiar, we do have a suction line on the system, but the economizer line coming off the flash tank doesn't go through the suction side of the system. It feeds directly into the side of the compressor housing, and it bypasses the motor. So if you look at the video, the valve we were cycling with a magnet, that is the economizer valve, and that is the line that goes directly back to the top of the flash tank. So when liquid was allowed to flow through there, it was just a direct injection straight into the suction side of the screw bolt assembly, which is where all of the liquid flush happened. And the only way that system knows that could have happened is the discharge superheat. The issue with that is it was severe enough that by the time the discharge superheat knew something was wrong, the compressor damage had already been done. Everything had already happened. I do want to say that I was talking to Brett Wetzel with the Advanced Refrigeration podcast over the weekend, and we were chatting about it on the phone. And he actually brought up a pretty good point of something they do in a lot of like rack style systems or cascades, is they have just float sensors for that type of situation, because they do similar things on their end of it, just in a different way. And I completely agree with him. So I think something that York could have done here that would have completely eliminated this, and genuinely, I don't know that they considered this as a possibility. I mean, they're pretty good at what they do. They make good equipment, so their engineers should have been able to think this scenario out of, okay, this liquid level sensor fails, the system doesn't realize it failed, now what? But anyway, if there was a liquid level float safety in the top of that flash tank or somewhere in that tank, to where if the liquid level was allowed to activate that sensor, it would stop operation, that would have been a really handy modification. Now with the newer series and the YVAAs and such, it doesn't really matter with those because they don't fill the flash tank in the same way. It's not even metered. They don't have a drain valve on those. So anyway, that's something that York could have done, but ultimately this is a failure that is pretty specific in terms of the chiller world to how York designed that, because they put no safety at all on that economizer pipe coming back, and they're fully reliant on that liquid level sensor to register that there's a problem until it fails. Because so with that tank at full level, we're talking at maxed out, we were only registering 5% on the liquid level sensor. Once we got it completely drained down to just an inch left in the bottom of that tank, it was still reading like 2% on the sensor, which is just, it's no good, absolutely bad. Anyway, so why didn't we start with a full recovery? Well, and that's where, so you enter into the scene and the video and everything that was happening as we were trying to pull down the evaporator. So we'd already gotten there that morning. We got the loop in the building under control and started moving on trying to get it repaired and fixed and so forth. So initially, and most of the time, you know, it looked like at first just a general migration. You know, it happens with migration. You know, things fail and migration happens, and it is what it is. So I thought that was just all we were dealing with, was just a regular migration problem. So I was trying to do that. What I underestimated was the severity of the migration. It was extremely severe. That evaporator was heavily flooded with a refrigerant, way more than I anticipated at first. And then two, I did not realize at the time that the flash tank level was at that high. I had no reason to, really. So that was the initial thing. And most of the time, you know, you're balancing a thing between, so during this service call, I had three total compressors down. And the other two, I felt were going to take more time, at least up front. And one of them definitely did. The other one was a faster diagnosis, but that third one, the third diagnosis, was a dead compressor as well. Something had happened electrically to it, and the compressor locked up. As a whole nother thing I'm not going to get into. But that was my rock and a hard place, is I had to choose between those three which one we were going to prioritize. And to me at that time, the one I went to, you know, the chiller one, made the most sense. So we were balancing how fast we can do this versus, you know, what does it need in order to get it fixed and online. So most of the time, if you've got just a minor migration, which in my mind, I just pulled a whole bunch of stuff off of the evaporator and was putting it back into the liquid line. You know, I'd gone through this whole process, so there shouldn't be much back left in that evaporator in my head. So usually the compressor can overcome that without too much trouble. And this particular system, I knew that I didn't have any oil in the separator, which I didn't like that. And we did add some oil to the compressor itself to help create an oil seal so they can pump better. Anyway, once you get them online and they get just a little bit of runtime and you start to get that refrigerant flow going, that oil will pretty quickly return, and it doesn't take a whole lot of time. So that's what I was counting on, was going off of that prior experience, trying to get that oil to come back, and then just what little bit of straggler was left in the evaporator, just clear that out. But again, at this point, I didn't understand the root cause, nor did I also severely underestimated the severity of how it was. If I would have the alternative option was to do a complete recover absolutely everything, pull the system down with the recovery machine, and then put it all back into the high side of the system. And basically that would be almost like hitting a reset switch. May not have changed. I don't know that it would have changed anything for the compressor. But partway through the video, specifically once we identified that economizer line was flooding, which I put some text on the screen, and I don't know if you can kind of hear some of the audio, but my coworker was actually telling me, hey, this economizer line is freezing over, which is an indicator of liquid flowing. That's when we realized that what actually happened, and we started digging into the flash tank. And so from there, we knew why it failed. We knew what happened, and the whole picture began to get more clear. And so why we didn't then go directly into a full recovery and basically start over was we were trying to cut corners. At least I was. Some of my colleagues and those that were up there, and we were trying to talk it out. We were more than once, we almost just stopped and started to pull all the refrigerant. More than once. It was very tempting. Some of the guys really felt that was going to be a better option. It was me personally, I chose to try to cut corners myself, and that was a mistake that I made at that time. I should have taken some of that counsel or just tried the alternative option. Anyway, the point is, we needed to confirm, is this compressor viable? So we know what failed, we know why it failed, the whole picture makes sense. We didn't understand why the discharge pressure was dropping at that point. That came later. Just if we put the time in, because a recovery like that is not a small ordeal, it takes a lot of time. And so in my mind, I'm thinking, okay, so we risk an hour of troubleshooting versus several hours or a good portion of a day in recovery. That was kind of the options being weighed here. And again, we still have other circuits we got to go fix. So it just, the whole balancing act of it, and when you're making those decisions in the moment, that's where we kind of landed on, or at least that's where I landed on, and the sequence of why we did each step. Again, hindsight, I will next time I run into a situation like this, recover all of that charge. And the reason I think we haven't really seen this very much is because we have a ton of these chillers in our area, but most of them are pretty similar in their life cycle. And so what that leads to is those sensors have about the same duty time put on them. So with that same duty time, I'm expecting over the next several years, we're probably going to see more of these liquid level sensors begin to fail over time. And as they fail, I'm not going to be surprised if we run into more of these, but I think that's also why we haven't ran into these, because overall liquid level sensors are an extremely simple device. They don't really fail that much, at least not that I've seen, and they're definitely not the first thing I think of when we run into a situation like that by far. So that's what we are, that's something we know to look for, especially if we see that we had some kind of flood condition, or we've got a severe migration issue or anything of that nature. We can approach it much more cautiously. I will say that one of the comments, and I pinned him in the comments feed. Let me see if I can find his comment, but he showed to be a factory guy. I really hope I can hope I can find him here. He had a wonderful, it was a lengthy comment, but why is it not coming up? Where'd it go? Oh, here we go. No. Anyway, we had a really good commenter jump on. Again, I see why it's not coming up. Here we go. Really good comment jump on and was talking about, so he was there when these machines were first getting developed, from what he was saying, and and him explaining the story And this was actually something that when the machines were first released, some of the factory guys who were involved in that process saw this a little bit, and they addressed some of those level sensor issues. And then eventually they got it all resolved from my takeaway from what he was telling us. So it was interesting input, because I really wish we could have connected with him earlier on in the troubleshoot. I think he would have had some really solid input for us, and trying to figure out just why that was happening in the first place. I really wish I could find it. There's a lot of comments on this. Oh, here we go. So Samuel Arenda. So I pinned his comment. Also hit the little like heart thing, whatever you call that. But it should be pinned in the comment feed. I highly recommend you go in and read his experience and how some of the things they went through during the early days of this series. And this apparently was something that they faced. And doing a full recovery is part of one of the things they did, was the migration and fixing all that, yada yada. One of the things that also came up was trying to the pressure drop that was happening on the discharge. Just if the Alphonse, I did respond to you on Messenger. So if you want to jump on there, go in that Messenger chat. I got back to you there, buddy. I'll help you finish working through that. Anyway, just in short, I don't know. I wasn't sure how else to explain it, but it comes down to a condition that technically should never exist. We should never be in a position to where we have standing liquid in our discharge side of the system, and we shouldn't be having that much liquid injection directly go into our discharge. I mean, we've got bypass systems, but this was a full-on just liquid flood hitting the discharge piping itself. And even though compression was happening, what wasn't happening was heat input into that refrigerant that was boiling. And that's really what it came down to. The compressor generates heat, and heat of compression happens. All those things are happening, but not at a rate at which the liquid refrigerant is taking that heat in. So that's really what it came down to, is that refrigerant, as it was boiling off in the discharge side of the system, as weird as that is to say out loud, that was causing the temperature to drop extremely. And when I say, that discharge line was literally getting a film of ice over it, from coming out of the base of the compressor all the way up until it 90'd again to go over to the oil separator. That whole section of pipe was turning into a block of ice when the compressor was running. So it's just purely PT chart. That temperature was nosediving like crazy. And if it was just gas in there, gas doesn't have the ability to absorb heat that quickly, but liquid refrigerant boiling does. So hopefully that made sense, and that's the sense I made of it while I was there. I was just kind of popped in my brain. We were talking about it and I was thinking through it, and it just kind of, one of those moments, it hits you. Oh yeah, okay, so that makes sense. Let's go back to refrigeration 101. Anyway, I'm going to be wrapping this up. I didn't want this to be very long. I just wanted to kind of hit some of the major points. If you have any final significant questions, let's try to punch those in real quick. I've got a very busy schedule still ahead of me today. Can you elaborate on the vapor lock? Thank you for bringing that up. Okay. So what I meant by the vapor lock is, so in a chill water system, or just any kind of closed loop in general, you can have pockets of things that kind of lock flow. So for example, if you get a pocket of air into a water loop, that pocket of air can get trapped in a particular spot, like say in a coil or higher up in the riser, and it will literally lock flow. It's almost as if somebody closed the valve, and it's considered a vapor lock condition, and you need to give that in a water loop's case, the air somewhere to escape, so that it can continue flowing elsewhere. Because you got to think in a closed loop system like that, you've got to push and pull kind of all at the same time, and the way the physics of it all works, there is the potential to where just literally everything locks up because of something that shouldn't be there. So for example, I said vapor lock because that's the term we're familiar with. This would technically be more of a liquid lock. So the theory is, and this is a theory, you can't really prove it. Yeah, okay, yeah, so like a P-trap theory, but the theory is that in the evaporator itself, we had a severe oil migration, and so that oil stacked heavy enough and consolidated in the evaporator tubing to where it filled up the tubing completely, to where top to bottom and certain portions of that evaporator was standing oil, right, all the way. And we know that evaporator had a tremendous amount of oil, because when we started to pull the refrigerant back out of it, that refrigerant was extremely oil saturated. I mean, extremely, which is just all part of the migration and the flooding push out and just all the symptoms we were having. That only was continuing to confirm what we already knew. So that was kind of helping us just see. So the oil acted as a pocket of air would in a chill water loop, except in this case, we've got liquid and vapor refrigerant, and the heavy oil was creating a vapor lock barrier, if you will. So how we overcome that was by giving an alternative flow source. So by running a 1/4-inch hose from the discharge to the suction side directly, and completely bypassing all the coils, and then by activating, so after we drained the flash tank, we didn't have the full column of liquid in it anymore, so it was truly vapor at this point. Then by activating the economizer valve, we were able to overcome that vapor lock, because we caused the whole system to kind of shift, if you will. I don't know, just something about it. I can't explain it in a really in-depth or technical way, but it created a shift in that oil placement. And when that shift happened, it allowed us to start pulling that oil through, and it broke the lock. And that's really what it boiled down to. It broke the lock that was created by the oil and the push and pull effect that the compressor was generating, so that everything began to just flow again. And we never had that issue after that. Once we broke the vapor lock, those symptoms completely stopped. That was no longer a problem. So anyway, it was a pretty interesting theory. It wasn't mine. We were heavily discussing it. One of my coworkers come up with it. I give him the credit for that. Very brilliant guy. Has been in the trade for about 40 years, doing chiller side work. But yeah, it's his theory. We talked about it. That was our experiment to see, okay, well, if we have it, we don't have a bleeder valve to open somewhere to dump water out, because, well, ozone and EPA and all that. So our alternative to that was doing the bypass. By bypassing where the vapor lock was, it was enough to jar the system, and then we had flow again. Okay, final questions, and then we're all gonna go cram our lunch and get back to work. Kind of breezing through. Any final questions? Otherwise, I'm going to close this out, fellas. I think a lot of kind of the, I guess, the smaller questions that come up, we kind of answered as we went. So there was one small question while everybody's kind of doing their thing. Did the customer, were they okay paying that labor? So in a commercial sense, especially what we do, we may have a single troubleshoot last a week. Okay, and that's just not uncommon, and sometimes it requires a lot of manpower to troubleshoot certain things. So that's something that's dramatically different about heavy commercial and even industrial than typically what you would see in light commercial or especially residential. Something like that would never fly there, but that is pretty common practice on our side of the industry, and the customers understand that. They ultimately, it's in their best interest. We're investing a lot of resources to fix their problem, and they want their problem fixed. So sometimes that means they get a pretty significant bill, but their system works, or they get the answer that they need, right? So that's just kind of a different side of the industry, I guess. I touched on that. See, question from Sterling: does the unit not have an envelope fault where it looks at discharge temp, high pressure, low pressure, etc., and locks up if it goes out of the envelope? No, at least not that I'm aware of. If it does, yeah, not that I'm aware of. It's got so it has a discharge superheat fault, which is what it should have tripped on. But from what I can tell, before the system could even register, because all those are thermistors, so they take time to even see it. You know, it's several seconds have gone by before it even notices that the discharge superheat's plummeting. Right? It's not a real time temp. So there's a lot of time that can transpire during that. So the system tripped on a motor overcurrent as the first alarm, which is horrible, because what that means is it puts so much stress on the bolts themselves that it tripped the motor on current instead of one of the other safeties. We'd really much rather catch it first. They didn't catch it fast enough, so the motor current did, which is just further evidence that the damage had been done from up front, which is the whole second half of the video is just strictly that. Is this compressor viable? It wasn't. We said it's right, it's over it. Had to move on. Okay. Appreciate it, fellas. Glad everybody enjoyed it. It was definitely a learning experience in a lot of ways. So, final follow-up. I made a comment, so I thought, when I made a comment towards whether we were going to repair it or not. They actually did decide to repair due to the lead time on new chillers. They do still plan to replace the chillers, but they have a significant lead time on them. We have discussed doing rentals as an option, but the rentals cost so much versus just fixing them that the customer decided that it was in their best interest to repair them. So we are going to be repairing this system at some point. The compressors are a couple of months out currently, so we have those inbounds, and we'll see what that turns into. Anyway, that was the final conclusion of the whole thing. Is we are going to fix this system. We're going to get it back online, and eventually in the next couple of years we're going to replace it. So see you guys. Appreciate you. Stay safe. Enjoy your lunch. I'll catch you around.